Okay. So today the question I did for CSES was called nested ranges check. So given in ranges, your task is to determine for each range if it contains some other range and if some other range contains it. Range A to B contains range C to D if it's inside that. So we have the input, which is a n, the number of ranges, and afterwards it says all the ranges put in together. And then the output is either first line is just whether or not it contains the range, and the second one is if it's contained. So we have an example over here. So the idea behind this is that if we're just going to brute force it, then it's going to be we're going to have to iterate through the list twice, like going through all the ranges twice, which would not work out because it's n squared and we're going to run out of time. So instead, we're going to just define kind of our own thing, like our own structure, so that we can compare. Um, we keep the starting point of the thing sorted in sorted order, ascending order, and then we keep the second term in descending order if it's equal, in the equal case, because this way we can ensure that when we check from left to right, we only have to go through, check the left elements. And if we're going from right to left, then we only have to track the right element. What do I'll kind of walk you through the code when I go through it. So inside here, we're going to include std++.h, and then we define our own structure called range, and then we have x, y, and index. Index is just to keep track of it because we're going to sort it, so we want to keep track of what the original order was so that we can go back to it. And then we define our own compare, which we have our constant range NA and B. And then if we first sort the x in ascending order, and in the case that it's equal, we're going to make sure that the y is in descending order. So that's going to be that's what we're doing. And then in our main function, okay, so then in our main function, we're going to start off by making the input and output slightly faster with this. Then we have we input our in, and then we create our ranges, a vector of it. And then with that, we're going to input the things. We get our X and then we get our Y into this. My bad. And then we just set our index to be whatever the order was indexed. And now we're going to sort it based on the whole thing. And then we're going to use compare as the thing that we use to sort it. And then afterwards, we create our two kind of output vectors, the contains and the contained. For the contains, what we do is we kind of go from left to right. And then, I mean, for the contain, yeah, contain, like E with the ED. What we do is we go from left to right with our for loop. We start off at 0 all the way up to n. And then what we do is our current max y is set to 0. And then if we found out that there's something greater than this, then we're going to, like, if it's included in that, then we're going to make our contain to be set to 1. So then it is contained. Otherwise, it wouldn't be. So we just update our maximum to be the current maximum of the y's. Why does this exactly work out? It's because if we think about going from the left-hand side, we're already sorting it. The list is already sorted in ascending order based on X. So then if something was contained, then like the index over here would have been within it, right? So then that's kind of what we're going to do is that the current maximum is great greater than or equal to our current maximum, like the current y value. So then um it's within the range. Like our thing would be just inside it because um I can kind of draw a picture. I think it would make more sense if I draw a picture to explain it rather than just kind of me handling over. Um, Let me share my screen. Okay, so inside here, what I mean is, for instance, we know that it's sorted, right? So then our um new list, which we have, is definitely part of the past list. And if our past list was ended, the maximum ended off somewhere here, we're guaranteed that this side holds. So if our maximum is greater than our current value, then it means our thing is contained inside this list. Because this thing happened before the thing. So then it means that this one must have been um, smaller than this one, smaller than or equal to this side. So this boundary, the left-hand side boundary is definitely true. And on the right-hand side, if the maximum is greater than that, then for sure it's contained. So that's why when we go from the left to right, we're just checking the contain function. So we're going to check contain over here. And then we go by the maximum value. And it's the same logic when we work from the right to the left. If we're guaranteed that the right here is definitely something less than this. And then if there was something, then it would be the minimum, right? If the minimum was within this, then it means that like if this was the minimum and this was smaller than like greater than that, then it wouldn't mean that this one was contains that thing. So then this one would check for contains as we the go from this side, go from the end of the thing to the other side. So then this is from 0 to n. Whereas this one is from n to 0. So like it's just making sure that when we're going from the left, we're checking the contain because the left-hand side boundary works, and then the right-hand side boundary would be max. And then the reverse would be true for the greater one, and then the minimum to be the boundary. Cool. I think I that is a lot more clear than me just trying to handle it with my hands. So that's kind of the logic behind here is that I set my current maximum to be that boundary as I'm moving from the left to right, and I check this. And then this is just the reverse logic. I just set a very big value here, and I move from the right to the left, and I make sure that I update my minimum boundary. And then I set my flags to be 1 if it's true. If it's not, then it's 0. And then in the end, I just output what my contains and contain based on my index I. And then I output the thing and then I return 0, which is the end of my program. I think the major thing for this question was just kind of knowing, okay, what can you do to kind of define your own structure so that you can compare, and then afterwards kind of working with the minimum and maximum boundary so that you logic and reason through it. Cool, let's end off here.